Hi everyone, my name is Terry Walters. You can reach me, Terry at Hazelcast. It's T-E-R-Y, pretty easy. I don't know, I've been doing Java since Java came out. Been doing programming, I guess, since the early 90s. I guess, companies like AT&T and companies like McKesson and UPS and mostly industry leaders. I've had the privilege of being inside of some of the top companies, some of the companies that, if we say top 10 websites on the planet, I've probably been inside of 7 of them. So I can talk to you about what it takes to scale applications, and I'm not talking about what looks good white paper. I'm talking about what it actually means for Apple, for example, when you use the App Store with your phones and devices, they use Hazelcast. If you're dealing with, I can ramble all these off, but it really comes down to some fundamental issues. A few rules, and those rules are pretty simple. For example, anybody in here ever use Netflix or Hulu or any over-the-top? Yeah, of course, we all do, right? So the reality is, one of the first things you'll notice is that they push content to your device. In the industry, we call that edge caching, pushing it out all the way to the device. And that's like your sweetest spot, because if the device has it, it reduces the network calls. If I can service that request from this phone without having to call a back-end resource, I have saved that back-end resource. I have saved the TCP sockets. I have saved the connectivity. I've saved a lot. So that's a really cool thing to do. So that's like rule number 1. How can I service that call without even making a remote call? Rule number 2, which kind of comes into tonight's theme, and also that guy, what's his name, Larry? Back in the 70s, he took a concept that was, Larry Ellison, he took a concept that was only on mainframes, and he brought it to the PCs, right? What did he do? Come on, man, what did he do? Yes, you. What did he do? Nothing? Okay, that's okay. He actually created a stored procedure. I know we hate those things, right? God, I've spent 20 years trying to get rid of those things. Why does every single Java, C++, Erlang, throw your favorite language out? And I'll tell you why it's going to fail when it competes to that stored procedure. First thing you've got to do is lock the data. Because, hey, I can't have her changing it. I got to lock it. Then I got to fetch the data. Now I'm going to mutate the data. Now I'm going to put the data back. Now I'm going to relinquish the lock. Well, the reverse of flipping you off will be those 4 fingers. All 4 of those calls are remote. What the stored proc did? Didn't move it, didn't lock it, just mutated it. Mutated, done. Why? Because it owns the data by the very thread that owns the data. So it's atomic. Oh, what a beautiful thing, right? Unfortunately, as Oracle has found out, and all other database vendors for that matter, it's not very scalable when you're talking about web scale. If we're talking about, again, just AT&T, back when I was there, 120 million of these little puppies, right? That's a lot of concurrent calls. Unfortunately, we animals don't turn those things off, so they're always doing things. So you want to co-locate your process with your data, which is exactly what the heck is DAG? Directed Acyclic Graph. Am I geeking out now? And now I no longer have control. Oh, there we go. So yeah, memory, the evolution, blah, blah, blah. We all know Hadoop kind of cut the teeth in the industry outside of Google, of course. Google pretty much was the first ones. But outside of that, in the open source world, Hadoop nailed it. They got it. They were the first ones there. That's literally a first generation machine learning. You could do lots of wonderful things. Unfortunately, it's very file driven. There's MapReduce, of course, and there's a lot to that ecosystem. Second generation comes along. Some guys with longer hair than me at UC Berkeley says, hey man, I got this cool idea. I don't know what they were smoking. Yeah, I actually did. No, just kidding. They had this idea of creating an abstract execution engine, right? They called it Spark, right? It's good stuff. very good stuff. Matter of fact, to this day, it is the industry leader in this space. It is a second generation machine learning language per se. It's behind TensorFlow. We were having a conversation about that before. TensorFlow is kind of Google's, if anybody in here participated in machine learning meetups, I think they're up in Alpharetta. Yeah, so Brad Weiderholt is my ex-coworker that lives up there, and that's why it's in Alpharetta, because that's where he lives. But yeah, so we do a lot with TensorFlow. The problem with TensorFlow that you get into immediately is that it does not support running on your hardware. TensorFlow, which is a beautiful Google engine, unfortunately is to promote managed services from Google, because that's the only place it works. So you can't run it on your watch or whatever the case is. And this is kind of all background, to be perfectly honest. I know y'all want to get into image recognition. I wanted to call this not hot dog. Maybe 2 people in here get it, Silicon Valley. Okay, so because the reality is we can use JET. You can use any of these machine learning languages to do this, but it really comes down to effort, cost, and how much, well, pretty much those 2 things, right? So a DAG, where does that word even come from? I think mathematically it came before Spark, but Spark pretty much standardized it. They, being a second generation, or they directed acyclic graph, and it's literally what, I don't know, Drools. I mean, rules engines have been doing this forever. There was a giant book called Enterprise Integration Patterns about 2005 or something like that. They did this. I mean, it's got many names over the years, but fundamentally, a DAG has a very specific definition as far as what you can do and how you're dealing with state management. So it's a nice, clean interface for doing mass compute. And when I say mass compute, I mean not just parallel threads on a machine, on a JVM or one specific machine, but also being able to have multi-state spread across multiple machines across a diverse cloud structure, meaning we've got some in Oracle, we've got some in Google, we've got some in Microsoft, and of course we have a lot in AWS because, well, they pretty much own it, right? Google's cheapest right now, though. But the point, though, is that DAG is pretty much, the terminology or the new architecture per se. So yeah, data flow, of course, being TensorFlow for production, is a managed service. And that's the latest, pretty much, until 2015, when a company called Hazelcast, one of the absolute leaders and the fastest in-memory data grid out there, and one of the highest open source activity. I think we're over 50 million. Let's see. Let's talk more put up or shut up. So I'll come over here and let's see. Here's Google BigQuery, blah, blah, blah. We'll run that query real quick and see. It was 50. Yep, there we go. Bam, bam, bam. So that number right there is 50,265,864. That's what that number is. What that number represents, you can see way up there, it's Hazelcast production phone homes last 30 days for those SQL challenge people in the room. And that's BigQuery, of course, from Google. So yes, we have baked into our open source, all of our products have a phone home built in. You can absolutely turn them off, as most people do, which that's why that number is actually small. The AT&Ts, the Apples, the top 5 financial institutes that are in your pocket. I can't name them because we're not under NDA, but the reality is they all have the phone homes turned off. So our largest networks, our largest clusters, don't phone home, of course. But so yeah, so what makes a 3rd generation system? Well, it's got to be DAG based, because they pretty much, Spark set the standard when they came out with the DAG approach. Now, there's some, if you follow Spark, you'll see that they fundamentally have now moving away from RDDs, which is another topic entirely. But fundamentally, it learns from your previous system. You're informed by the academic papers, because let's face it, when it comes to machine learning, your DARPAs, your universities and governments for that matter tend to have the most to gain. So they have the kind of the most contributions, and that they're contributing the most. And of course, there's a crazy amount of choice. So if you look at, again, using Google Trends, you can see that Hadoop, while certainly was massive, it's declining. I mean, it's not a death march yet, but it's pretty close. So you can see the very first generation is now trending down pretty sharply, actually, because, this is 14, so, and it's sad in one way, but it's also a realization, and that is, we all know, being in this field, that, if you lead, you bleed, right? So the reality is, once you get past the hype curve, which we'll get into here in a minute, it's what you can actually execute on, and then what's actually sustainable in production. And it changes, because what was one of the rules? You learn from your previous existence. Looking at the landscape today, if we spin Father Time back to the 90s or whatever, we had something called fat clients, right? And what was a fat client? It was basically you use C++ or whatever your language of choice is, and you created this application, and it made calls to all the services. Sounds like SOA, right? Service-oriented architecture. Oh, wait a second. But maybe it was event-driven as well, but maybe it was microservice. But the reality is we had these fat clients. Well, what's the fat client today? Fat client today is HTML5, right? I mean, we now have a SQL engine, we have a threading model, we have sockets, and thanks to Google's Speedy protocol, we now have HTTP 2, which is amazing. Hazelcast, if you look at our open source, our IMDG product, we have an open binary protocol, and if you look at Speedy, it's like those guys were talking to one another. Jacobson over at Google, who created V8, of course, which is today known by everybody as Node, I guess. That protocol, Speedy, is what led to the creation of HTTP2. What was that, like 3 years ago, right? So if you look at our binary protocol, it's very, very, very similar. So there's the hype curve, some little points of interest, blah, blah, blah. There's too much material here for me to cover. This will certainly be recorded as well as be available online. But fundamentally, what all this is really giving you the background for this space, and that is, what is the first generation, what's the second generation, and what makes you third generation, and what does that mean from a programmer's perspective as far as getting things done? So yeah, Spark is definitely dominant, and it's definitely stable. You don't see a huge drop there per se. Let's go ahead. Yeah.
Yeah. So you can see the Hadoop is going down, but at the same time, the Apache Spark is not going that much up. It is staying. Why? What is the reason?
That's a very astute observation. I don't know if everybody heard, but she pointed out the fact that yes, Spark is stable, but it's not it's not growing, right? And there's a good reason why it's not growing, because what took Hadoop 4 or 6 years is now being done in 2 years, So the reality is, what does the industry do? And you can apply this to your own company. It consolidates and shrinks, right? In the beginning, it's like everybody's an application server. I mean, I can do that because I'm a former BEA employee. I remember the app wars, WebSphere. I worked for BEA, so, we made fun of everybody else because we were the fastest. Just like Hazelcast, we make fun of everybody else because we're the fastest. So the reality is, what happens is the industry floods the market with all these different kinds. I mean, how many big data solutions are there? Who's Hazelcast? What is that? Couch? No. Is that Mongo? Wait, is that Redis? No. What is? There's throw a rock, right? But the industry will shrink back down, and only the kind of the best ones, or the ones with the most money sometimes, will be the winner, right? So it will shrink. So that's what like my opinion, we all have them and they all stink, My opinion is like an armpit. My opinion on it is that what you're seeing is that the industry itself is already recognizing that Spark is past its life. Why do I say that? I have customers that I won't necessarily name because we're not that close yet. But some of these customers do like an application where you record something and it tells you what you're listening to, for example. Things like that. And we're talking about on a very large scale, you know. And the point here is that they embraced this technology only for it not to keep up with the third generation solutions. So that's why, to me, it's plateaued. Yeah, we see a dip here, but I think it'll come back up, and it may actually stay that way forever. But I do definitely believe that you've got someone else coming in that's going to, be much higher. So yeah, let's see. A little bit more background, I guess. The rest of the pack, like I said, there's a whole mess of them out there. Kafka Streams, which is very prominent, of course. Google, Apache, a couple of Apache projects up there. They're always trying to learn from someone else and be the next one. But something that's missing from all of these is the ability to stand on the shoulders of the exact opposite of what Apache Spark was. I know it sounds crazy, but Spark, one of its downfalls is the fact that it's an abstract execution engine. If it's an abstract execution engine, then it can't take advantage of, say, localized or partitioned data. What does big data do? Well, we have to partition the data and then we replicate, right? One simply does not put big data on one machine, right? So the reality is you're going to divide the data up, and then you're going to replicate for backups where you want backups, but you're going to divide that data up. Well, if you're dividing the data up, Spark has to create, an RDD that represents that data. He has to flatten it out for him to be able to work on it. He can't take advantage of, you have 1/60th of the data, I have 1/60th, she has another 60th, and so on and so forth until we get all 60, right? In which case, remember that stored proc earlier? Why was it so daggone fast? Because it didn't have to lock the data. I don't have to know about you or you. I got my own, right? I don't have to lock it because I'm the guy that owns this data. So what should Spark do? Spark should take advantage, any abstract execute, see, that's where the rub comes in. It's no longer abstract when you're taking advantage of partitioned data, because now you have to know, how did you partition the data? Did you use a consistent hashing algorithm? How did you partition the data? What are the partitions? Who owns that data? What threads own it? Now you just left abstract and you got very, very personal with your data. And that's where, quite frankly, I think that the next generation, the third generation of these tools will be able to just blow your Hadoops and your Sparks away. And it really comes down to no longer being abstract. And again, we can talk about the word count, blah, 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 how bad that code is. You basically can get it into a DAG, a directed acyclic graph, which is basically like a workflow. You have a source, you have a sink, and you have some vertex. What the heck is a vertex? It's a process. You've been doing this your whole life. I'm reading some data, I'm working on some data, making a decision, maybe working on more data, maybe going back, and at some point I'm delivering data. Pretty simple. New words to something we've been doing for a very long time. But yeah, so fundamentally, it starts off really simple, but then computer science or any buffer smoothing pattern you introduce here, add a queue. What's that mean? You now can separate the work from the workers, right? So I can start scaling. All right, so that's one of the big things. The RDD approach does not allow you to do that. It's single, right? So once you've now introduced, these queues, you now can be multi-threaded here. You can say, hey, I can process multiple words at the same time because I happen to be on a multi-threaded machine or a multi-CPU machine, right? Pretty simple stuff. But again, comes back to how sophisticated is the architecture, because these graphs can get really complicated. The problems you're solving for your business today can get very, very messy. You know that because your whole goal in life is to solve these very complicated problems that the business analysts, and forgive me if you are analysts in here, but they don't really know what they want, right? They tell you what the requirements are, but they don't realize that requirement 1 and requirement 17 they're counterproductive, right? You got to pick one, right? So the reality is your job is to simplify that, to do it as simple as possible, because any idiot like me can add complexity, and solve the problem. But it's more important to make it simple. And this is where that comes in, because by adding that buffer smoothing pattern in here, you're able to scale out. And what's really neat is, I think in the past 2 years, Intel has introduced the Sandy Bridge or Sandy Plain or whatever the heck their new chipset's called. And now, I'm an old assembler guy, so I can tell you, your jump not equal to, you get into, So what they can do now is actually do array computation. What used to be like a loop, if you were iterating over, I don't know, some bounded set of data, it would literally break that down, and each one would be a comparison. You would compare each individual value. Not now. For the past 2 years, we've got array support on the chip, right? So if your software is taking advantage of paralleling, the process, ideally with, green threads, for example, then what that means is the JVM can invoke the array computation, which means now we can compare 32 values at one time, not 32 separate comparisons. I mean, we're literally executing 32 comparisons one timer tick. Trust me, that's a big deal. And it will expose your software. If you did not, go ahead. Yeah, green threads instead of native threads, for example. We'll get into that a little bit. I don't know what my time is. You have to watch me. I can go long, But yeah, so again, what the heck's JET? So again, this is all background to getting to the fun stuff of not hot dog or real-time image processing. So JET is pretty much a distributed data processing engine. It's very similar to Spark, except it's really the next generation of. It's completely open source. We're not ever going to charge money for JET, which is in direct conflict to IMDG. Hazelcast has 2 products. One is IMDG, the other one is JET. IMDG is open source as well, except if you want security and things like that, then we charge money for that. But we have a completely open source version as well, which what we were looking at earlier, the 50 million, most of those are open source. So JET, which is completely Apache licensed to open source, it is an execution engine that runs on top of IMDG. So you can run IMDG open source, you can run IMDG enterprise or whatever, but JET is always open source. And it's available in Maven right now. So if let's see how broken I can be. If I come over here to Maven repo, go to Hazelcast, and we see, there it is, JET. Do I have a connection? Maybe, yeah, sure we do. Then, of course, we have lots of different types of JET connectors, It's pretty straightforward. So 061 is what's available. It's a single 10 megabyte jar right there. Pretty straightforward. I can show you my POM file. You pull that one guy in and you're pretty much good to go. Gee, what have I been shopping for? Over here you can see, flowers and crap. I'm sorry, what? Mother's Day? Yeah, exactly. Good catch. So yeah, it is an abstract engine, yada, yada, yada. This is pretty much how you can think of these DAGs. This guy runs on top of this guy. You can read from anywhere you want, and you can write to anywhere you want. And today we're going to read from a camera, and we're going to write to a user interface. Why don't we do that now? So if you wanted to follow along, the source code, which we have in the links, it's Hazelcast JET demos. I think if you just go to Google and type Hazelcast Jet demos. It'll be the GitHub hit right here. You click that guy. And these are all you can clone that guy. And today we will be covering this one, which is the real-time image recognition right here. And this is the text that was sent out with today's meetup. And here's an example, you just, now speaking from experience, something that you may have to do is GitHub restricts the file sizes, and the data set that's an external data set, the CIFAR-10, that data set is, I don't know, it's kind of large. So you need to make sure you have what's called GitHub Large File Support, GLF, or GitHub Large Files Support, GFS. So make sure you do a GitHub GFS install before you check this project out. If you do it afterwards, it doesn't work. I know, I was tripping over that for about an hour until I realized that I did not have the GFS installed. So yeah, basically you get this guy, you clone him, and you clone his parent, and then of course you should have something like this. Over here you can see all the projects. Down here you can see there's 3 simple files. We've got, we have our real-time image recognition.java, we've got a webcam source.java, and we have a serialized buffer image.java. Now the whole reason why we have oh gosh, that went completely dark. Sorry for those, well, outside of about 10 feet here. I used the dark scheme. So what you're looking at here is simply a serialized version of the buffered image. Anybody want to know why we would need to use a serialized version of buffered image? Yes. Who spoke? Speak up.
Yes, we would like to know.
Oh, you would like to know. Well, I'm asking you, do you already know? Bingo. Who said that? Right there. Excellent. What he said was simply streams. Now, tell me more. I want to know.
Okay, if you have a stream of data flowing in, so you can actually start breaking up and tokenizing it, and then start your process, and then handle the data accordingly.
That's exactly right. So what he said is he's got a stream, and he's going to tokenize and just process on the stream. Anything going into a stream, or for that matter also out, must be serialized, which is a beautiful thing, because if it's serialized, that means we can move it across machines. Remember earlier I said web scale? I'm talking being able to use many machines. Yeah, if it's not serialized, I can't move it. Comes back to good old HTTP, the session, right? If you put something in the session, it's got to be serializable, right? Now, this is terrible code. The 3 rules that I mentioned earlier, one of them is near cache, edge caching. The second rule is co-locating your process with your data so that you reduce the number of network calls. Anybody know what the 3rd rule is? Anybody? It is shrink your payload. Yeah. Y'all are Java developers in here, right? So what's bad about Java serializable? Anybody?
You're serializing the whole object.
That's right. That's like number 1. We're serializing the whole object. What's something else? How does it serialize the whole object?
It is synchronous process.
It is synchronous, but what's even worse than that? Even though that's terrible. So if you've ever taken a wire snap, TCP dump, Ether, or whatever, grab a few packets. What you'll notice is when it literally uses runtime type information. It's like, hi, who are you and what are your name? Even though I already know because she told me just a few minutes ago. I'm going to ask her every single time I need to transport her on the wire, and I'm going to ask her again when I take her off the wire. So you're paying for it on both ends, Very, very painful. Also very bloated. I went up to a very large bank in Canada last year, and I, expected to find bad code, expected to find, they weren't, co-locating things. Their physical architecture was probably very disparate and all. I was expecting all these things. I was surprised. I was pleasantly surprised. They did everything right. I was looking at this code and I was thinking, wow, that's beautiful. It's sexy. It's like, wow, that's pretty creative. This is great. This is great. Physical architecture, co-located using placement groups, enhanced networking. They've recompiled their drivers to support multi-banded virtual CPUs to I/O buffers. All these wonderful things. So what gives? Banks like to use dates. They wrote their own serializing class, kudos, but they forgot Java date. And that is a boat anchor. Java date is a big, bloated piece of work. Very flexible, does everything, right? But unfortunately, it costs you an amazing amount on the wire. By turning their date objects into longs. I didn't even get queued. I didn't do any bit shifting. I didn't do anything queued. I just said date, current millis, wire. Wire, current millis, date. Give it back. Wonka vision, Anyways, I'm shrinking it on the wire and then unshrinking it on the other side. No big deal. 300% performance increase. 3 with 2 zeros. Just by changing the format on the wire. Did I mention they like to use dates? So yeah, so those are pretty much your 3 rules. You want to make sure that you use edge caching wherever possible to service the request without any calls at all. You want to make sure that you co-locate your process with your data. And then of course you want to shrink what's on the wire. And that's why I said this code right here is terrible, because as you can see, it implements serializable. That's because the guy who wrote that was incredibly lazy. It's real easy to say implement serializable and go on about your life. If you want to use externalizable, if you want to use any one of the more optimal ones, Cairo, I mean, don't listen to me, do your own profiling with your data, and that's what's always going to be best. But I can tell you this, don't use Java serializable. I mean, use it for demonstration, but don't use it in production. It's not production quality code. So we got a read object, we got a write object, pretty simple. And yes, that's because we are using it in a stream. We now have another class here, which is the webcam source. We are cheating. We'll see that there's an import of a project called Booth CV, and that's where we're actually getting this webcam source. And as you can see, we're doing a stream processor. So pretty straight, pretty simple. It's a pretty small amount of code for what's actually being done. And then the real meat is over here in something called real-time image recognition.java. I know the comments are kind of funny having ASCII art, but fundamentally what we're doing here is we're actually documenting that DAG. And this one's really kind of boring, to be perfectly honest. It's just a straight line. We've got a webcam video source. We enrich it with a timestamp, and then we classify it with a pre-trained model, and that's where that CIFAR10 data set comes in. Then we have calculate maximum score in a 1-second window, and then we have show results on GUI. So all of that for documentation, blah, 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 and then of course, we'll see we're looking at some logging. We've got checking for a parameter, and then we instantiate a pipeline. We do a jet instance, and then we join the job, and then we do a shutdown. What's the job? Here he is. Again, remember earlier I said level of effort? That's a DAG. That's a pipeline, actually. This is kind of a, if you've used Java util streams, and if you saw my presentation at DevNexus on writing the jet streams, it's very similar. The difference is, of course, Java util streams kind of cuts one of your legs off, because you can multi-thread, but when it comes to actually trying to distribute that across many, many machines, that's where it doesn't support multiple state management. So you can't actually get truly the throughput that you'd like. I mean, Java util streams by default is only on one machine. You can't do it more than one. But those of us that have tried to make that API run across multiple machines, it's good, but it's nowhere near as sophisticated as a pipeline. which is exactly what Google Dataflow has embraced, pipeline, exactly what Spark, the next generation, has started tinkering with, exactly what, so that's really the third generation are all pipeline based. So what you'll see here is we got a pipeline we create, then we draw from webcam, we add the timestamp, we add our classifier context with a tumbling window of 1,000 milliseconds, and we aggregate by the maximum value of, and this is a really long line, but basically it's just getting the value from the classifier, and then we drain to our GUI sink, and the GUI sink is the user interface, which is right here. Let's see. So this is it right here. So this is basically using a swing panel. Pretty straightforward, right? We're just adding the image and then scrolling to the bottom and repainting. Any questions about the rather abbreviated source code I just showed you? The two things that in this source code is kind of cheating. One, we're using a Hazelcast jet. So that simplifies what's happening behind the scenes, because that engine is able to run at scale. You don't have to be concerned about it, just like you didn't have to be concerned about maps with IMDG. So the other one is we are using a third party for the scores, right? We're using the CIFAR 10 database, which is a trained model. If we come over here, I'll probably have it. There's the image classifier. I just type CIFAR 10. It's right here. So this is pretty much it. And this is in the slides, so when you get the slides, you'll get this as well. But pretty much 10 different ones, as you can see, and it's a pretty dumb set, 10 different categories, which I've got some sitting over here for that exact reason. We have a horse, a deer, one of my vehicles, which is not on that list, and then one of my other vehicles. So now we'll just go ahead and run the puppy. Let's see. Just did a Maven execute Java. Sorry if the font is so small. I probably can work on that. There's our jet. There's our DAG. Shows the vertex coming up, blah, blah, blah. There's the source code, quite literally. And there I am. Oh my gosh, this looks terrible. Let me move some windows around. And what are we looking at here? Well, Bob, what'd you win? Over here is the webcam source. And over here is it trying, it called me a horse. Now it calls me an airplane. So we're gonna point it down away from my ugly mug, and let's do a positive test. Let's see, what is that? Uh-oh, I just pulled my mic down. It says it's an automobile. Woohoo! It worked. Oh my God, a live demo that worked. Yeah, so it's actually pretty confident. It's got a 10 score. 9-4. But as you can see, it thinks that's an automobile. That's not an automobile. That's a Corvette. What's something that it doesn't recognize? Right there. That's my lovely, lovely Dival. Love that bike. Wonderful bike. That's us in the background on it. It thinks that's an automobile. That is incorrect. If you said vehicle, I would say yes, but you said it's right with an automobile. I think an automobile constitutes 4 wheels. So, not to argue. But in either case, this is an example where the data set does not know about this. So this is a successful negative path, right? The data set does not know about. If we had said CIFAR 100, which has 100 different categories, it has the vehicles, which understands motorcycles. It did classify it as a horse?
It did not. That's a positive, right? Not a hot dog.
It's not a hot dog. Exactly. So I don't know, at this point, it thinks it's an automobile. It's got a, let's see what it thinks a horse is. Did that get in there? I don't know. Is it able to, it sees it as a horse. So it does know horse. Oh, wow, the slow motion. Yeah, so it does know, oh, it thinks it's a deer. Oh, I see why it thinks it's a deer. Do you see that? Because there's not a clear head. We can correct that, I think, just by getting rid of the background noise that's taking place here. There we go. So it's got a clean shot of the head. It's kind of important that he recognizes that as a horse because deer is one of the other ones up there that has some stuff on his head. So now it says, oh, it is a horse. Even though it's still kind of, you can see the edge up there. Right? So let's see what it thinks a deer really is. If I put a deer in there, deer in headlights, ha! I don't know why they don't just move those deer crossing signs. That would send the deer somewhere else so people would stop hitting them. But yeah, now it thinks that is a deer right there. Bam. So that's kind of cool. It's not hot dog. What was the question? I don't believe so. I think that is part of the machine learning process. It really is recognizing that off of 10 pictures of deer. That's it. I should have probably said that earlier. So, yeah, go ahead.
What type of neural network is that?
So this is actually using Booth CV, which is one of the, it came from, I forgot which university. One of the universities is working on this. It's Booth CV. It's in the source code as well. And you'll probably see it down here. Well, it was in the imports. But fundamentally, it's using, this is a 10 category model with 10 sample images. So if we look at the images, we probably can answer your question. So let's see, we already did a negative test. But yeah, so fundamentally, that's pretty much all there is to that puppy. So if what's it think? It thinks I'm a cat. I'm a dog. So yeah, so if we come back to presentation, maybe, sorta. Here's the data set, and you can see the deer. He's got a headshot there, a complete shot, a headshot, a far away shot that might confuse it with a deer, with a horse, because there's nothing on its head there. Antlers, I can't even make that out. A baby deer, no antlers. Big antlers. A doe, no tail, and I don't even know what the heck that is. But there's your sample set for the deer versus the horse, which is here in front of me. You can see the horse is identified with the longer tail, no antlers, obviously, headshot, person on horse. So there's the sample set, you see. So I think to answer your question, it's actually looking for the tail. It's looking at the tail, and it's looking at the head section. To identify the difference between horse and deer.
I think so. A couple of pictures there are showing only 2 wheels for the automobile, and that might be the reason why.
Oh, very good point. The automobile has 2 wheels over here and there. So, good point. Yeah. But as you can tell, the more you train your model, the better this gets, and that would be outside of the JET code per se, or whatever your machine learning code is. Yeah, go ahead. Yeah, it's a confidence score. It's very similar. Are you familiar with machine learning? Have you done like the traveling salesperson, for example? So when you do a fitness test, so that's what that represents. So a lower score obviously is lower confidence. Higher score is higher confidence. I think your acceptance is around 7 or 8. We'll have to look at the classifier code, which is part of this guy over here. Bam. This is not Hazelcast. This is open source. These are the people that actually created that code right there. It's Boof CV, Boof CV. But fundamentally, that's one of the many open source projects out there that are doing machine learning. So we just stole from them. Yeah, go ahead.
So over here, Hazelcast is getting used for source and sync, right?
We're being used for source and sync. Yes. What is the source and what is the sync? That's right. The webcam is the source, and the sync is?
This open source library.
No. Close. UI. The UI. So the source is actually, the webcam, and the sink is the graphical user interface. And to your point, this classifier, image classifier, VGG CFIR 10, that's the class, when we pull up the image classifier, image recognition, he instantiates this guy. So this is the guy that's actually calculating what the confidence score is. Yeah, go ahead.
Does JET have pre-trained libraries like you see with TensorFlow?
It does not. For the fundamentally, that's actually my wife in the back there. She was like, "Can I ask a question? I'm going to out you." She was like, "Can I ask a smart question?" I'm like, "Oh, you want to be Penny on Big Bang? Okay, yeah." So that was your question. Is exactly very similar to what she was asking, and that is, does the machine learning the ML Libs, the machine learning library from Spark work, integrate with JET? And it does, because it's just Java. At the end of the day, we integrated this guy. It could have been that guy. It could have been any of them. It's just Java. So to your point, to your question, we can work with any of them, but no, we do not bring those to the table. We are not machine learning experts. We're not even really algorithm experts. We're experts at scaling and data distribution and doing, mass, for data and for compute. We are not data scientists that do nothing but, think about better ways of figuring out the area under the curve or anything like that, right? So that's really more outside. So, yeah.
So basically this demo is showing us that how to use the JET engine to do image recognition.
Yeah.
That's the goal, and you can basically, this would have been done by a GPU or something?
Yeah, exactly. That was a great, I think that's what our goal was. Do y'all agree with him? He's saying this was a demonstration of how JET is used to do the the image recognition. But the reality is we could have used any one of the other demos, for example. I mean, I like this one because it ties into not hot dog. But we easily could have done. There's many other ones. Let's see. I think are we over at 8 o'clock?
10 to 8.
Okay, it's about 10 to 8 now. But fundamentally, when it comes to performance, of course, it goes without saying we pretty much blow what we do. We are the fastest in the industry. Lowest latency, yada, yada, yada. Huge community. Again, we have definitely one of the highest activity for an open source project. And of course, JET can be embedded or it can be in client server. That means you can literally import that library into your POM, and then if you instantiate the instance versus a client instance, it will literally run as part of in a microservice. You can run it in your service versus running client server. Let's see. We've looked at streaming and batching. All that's covered. There's competitive differences. Yada yada yada. But really, here's what I wanted to say. How is it better than? Oh, it's not better than Kafka streaming. It's not in that space. Kafka streaming doesn't do really distributed compute. Kafka streaming, which is good stuff, don't get me wrong. I lost one of my best colleagues to the Kafka streaming on managed services. But my point, though, is that that was Victor, by the way. But the point, though, is that JET is in competition with Spark. It's a next generation. It's literally a third GL version of Spark. Kafka streams, we have support for Kafka streams as sources and sinks. Quite honestly, you'd be surprised at how many of the top financial institutes on this planet are using some sort of either Kafka or Rabbit or some other queuing and streaming technology. So yeah, those are always a sink and a source, always. Well, not always, but more often than not. But here are some of the other demos. We seem to have an internet connection, so I could probably show another one since we are in Atlanta. So I could do let's do the flight telemetry one real quick. I think we got time for it if y'all are willing to put up with me. Let's see, there's like a flight demo. It's using Docker, so I'm going to do a make up, I think. I think I've already compiled, so we should be good. I should be able to just do a Maven exec Java. You would have to do a clean package or an install. But here's another one. If we look at his source code, the flight telemetry is far more complicated. As you can see here, this is reading real-time data from some flight system that publishes every plane like on the planet gets published along with the equipment type and all that kind of stuff. So what we're doing is we're calling that REST API and getting that in, and then we're enriching it with the CO2 information to show pollution. We're enriching it with the noise information based on the size of the engines, all that kind of stuff, and so on and so forth. And at the end of the day, we're publishing it to this really cool little UI, which I think I can probably pull up. Localhost, something like that. I don't know. Maybe it'll work. Flight telemetry, there we go. Yeah, it seems to be working. So yeah, we've had 0 takeoffs and 3 landings in the past 5 minutes. So if we say, I don't know, last 6 hours, something like that. So we'll start seeing, you know, this is another one of our demos that's certainly doing real-time statistics on flight. You know, all the planes on the planet that are taking off and landing. And then we're enriching it with the CO2 emissions and the noise in decibels, as you can see over there. Kind of neat. We've got some crypto ones on there. We've got some Markov chains, for example. We got lots of demos, but it's hard to demonstrate an engine. You know, at the end of the day, you know, we don't do flight data. We don't do machine learning. We're just the streaming engine. We're not the stream. We're the engine that takes if you like Java util streams, you will love Jet. You will find Jet to be like, wow, where was this, you know, when Java 8 first came out? Yeah, go ahead, man.
So since you're streaming data, right, so in an enterprise, when you're trying to do one application I can think of is click stream processing.
Oh, yeah, that's a great one. We've got, yeah.
So when you do click stream processing, sometimes you want to do something like complex event processing.
That's right. That's right. So what he's talking about is click stream processing, and that leads you into CEP, complex event processing, which is a really messed up word for doing multiple things on the same thing. So that brings up a very important topic, and that is the sophistication of your engine really can make or break you. And it kind of plays into Jet because Jet supports multiple windowing. What that means, like Spark doesn't, even their latest one does not. The 2.3 doesn't support it. And what I showed earlier was a tumbling window of 1,000 millis. That meant that, you know, it was literally looking at 1 second of data and then the next second of data, and then some people call that cascading in the math community, but we call it tumbling. But it's the same thing. It's literally a second and then another second and then another second and so on and so forth. Versus when you have a sliding window, right? I could have a sliding window. There's a second, but those seconds overlap right here, and that might be something you want to do. You might want to, like, if you ever have done CDC, not the little disease place, the more important CDC, the change data capture, for example. So if you've ever had to work with binary transaction logs, then you know that you only have the latest state, right? If you only have the latest state, well, you got to rebuild the whole transaction, right? You got to know that, oh, well, I'm updating a record that you don't know about. You just see the update. So you got to know that way back here, that puppy was created. So hold on to that. She did something, and he did something, and he did something, and I did something, and bam, now you're here. But you have to replay all that to get to that one spot. So that's why the different types of windowing matters, whether it's cascading, whether it's sliding, and then there's another one that I'm forgetting. It's in the slides. I left the slides a long time ago. But yeah, so fundamentally, how sophisticated the engine is lets you have a more discrete solution, which leads to less work. And you can ask anybody. I'm the laziest person you'll ever meet. But yeah, so having that, I wanted to have this T-shirt printed up for Hazelcast, and someone said no. But basically, it's being an older guy. I remember SendMail, and SendMail, which is responsible for probably most of the spam you've ever received in your life. SendMail had these t-shirts a long time ago. The greatest thing about SendMail is everything's configurable. And on the back, the worst thing about SendMail, everything's configurable. And you could say that about Hazelcast. It's true. We have a lot of parameters, and that's really what keeps me gainfully employed, is that, you know, I have to help people with tuning parameters. So, you know, that can definitely be, and it really comes back to people that are scaling at very high levels. For most people, works right out of the box. Our operational threads are 2 times the virtual CPU, and that's more often than not, that's a pretty good recommendation. Some cases, you might want to stray from that. But yeah, so let's see. I think we're pretty much the real time. This is the slides that pretty much cover what we've already gone over. There's a static of what we just did. Here's the architecture. Like I said before, Jet sits on top of IMDG, and that's what gives it all the distributed, you know, all the things that stored procedure that I was mentioning earlier does is done here by IMDG. So we don't have to reinvent an execution engine up here who needs to distribute data or who needs to do a latch or you know, flake IDs or anything like that. All that's done here. So we're not reinventing the wheel, which means we're also not abstract. You're not going to, you know, put that guy somewhere else. But it's a very robust, powerful architecture. It's very simple. Pretty much covered this already. Yep. And of course, tasklets. We didn't really talk about that, but that's really inside of a vertex. You can break them down into more tasklets. Again, this is where we were talking about earlier about green threads. You know, it's kind of a trade-off, you know, when you talk about native things, because I'm a hardware guy. I used to be a kernel developer and write device drivers and things of that nature and ring zero kind of crap. But fundamentally, green threads, if you're not dealing with I/O, a green thread will always be faster. But as soon as you're dealing with actual I/O, you need a native, which is why we have, you know, part of our paid product, which is not part of this, you know, is we have something that will run native for dealing with big memory. That's outside of the scope of this, though. That's called HD. But fundamentally, that's going off heap, things of that nature. Let's see. We didn't really talk about back pressure. But back pressure really comes down to the fact that when you start going to large distributed compute, you end up with what's called, in the TCP world, the pattern that's implemented there to transmit all the packets is a message scatter and message scatter, and message gather, right? He's scattering them and he's putting them back together. Well, the problem you get into, and we've all experienced it, what happened March of 2017, that for 45 minutes, no one had access to GitHub. What do you mean? Anybody know what failed? Anybody? Bueller in the back? No? You don't know what happened to GitHub? Nothing. Check it. Not one service failed, no DNS attack, nothing failed. Well, Terry, you just said nobody could access it. I did. GitHub was able to do something that most porn sites can't even do, which is saying a lot. They completely saturated 100. Oh, are you raising your hand? You can't answer because you travel with me and you know the answer. So she's not allowed to answer. So yeah, if I had the T-shirts, I'd give them away here. But fundamentally, what happened at GitHub is their dark fiber was able to get completely saturated, and they achieved over 80% collisions, which resulted in spurious retransmissions. Well, from a TCP perspective, that really exposes software that does not have strong consistency at the lock. Earlier we were talking about distributed processing, all these wonderful things, and one of the things that you get into is how are you doing your locks across more than one machine. I mean, understand Java's wicked at doing multi-threaded in one JVM. I mean, Erlang's good. I mean, I can talk great about lots of different languages, but in Java, it's pretty good about doing that. It makes it very, very accessible. Well, what happens when you're doing that across many machines, right? So now you have locking across resources, which has probably been on every single test, every single interview. Tell me about volatile. Tell me about, they're going to ask you on these kinds of questions, because it's only when it hits the fan that the pipe is full that you actually expose these things. But yeah, so, it really comes down to the sophistication of the implementation. So these are different sliding, tumbling, and session. Session. That was the one I forgot. So yeah, we got fixed, we got sliding, we got session. So, that's really the different types of windowing per se. And, that really allows you to be very precise with your implementation. Yeah, fault tolerance, blah, blah, blah. I can talk your up on that as well. We saw the flight telemetry demo, and we can talk about APIs. Like I said earlier, the Java util stream API is nowhere near as, like, for example, you can't do any joins. So when you get into the collect, it kind of falls apart because their API is lacking the distributed API because it was never made to be distributed. Let's see, pretty simple stuff. I know there's way more here than what we were going to cover. I wasn't sure about the time. There's some example code. We've seen that already. The Java util streams is very straightforward. Looks just like Java util streams because it is. The difference is we take it across multiple JVMs. The Java util streams are nowhere near as powerful as DAG. DAG is a far more lower level API, which is what we saw before. That's where you have the vertex and you can get into tasklets and you can do all kinds of, I can do my buffer smoothing pattern from vertex to vertex, and then I can have tasklets inside there. It can get as complicated as your solution needs. But sorry I went over, but that's pretty much it. And the code samples, like I said before, if you just type Hazelcast code samples, you can find it just like that. The Hazelcast Jet demos, again, if you just say Hazelcast Jet demos, you can find that. We've got upcoming events on that link. There's a webinar, I think May like the 20th. Marco, one of the chief architects for Jet in Croatia, will be giving that webinar here in the next week or two. I would highly recommend. He is far more concise than myself. I'll be down in Tampa for June 5th. That's some free training if you're looking to do some deep diving and some coding with all things Hazelcast. We'll have lots of other ones as well, but that's just the next one. Thank you very much. Thank you. My pleasure.